Hello, I'm David Valdés, and today I wanted to talk about graphing quadratic equations. And I'm going to do some introductions here and just go through several problems and show what graphing a quadratic equation looks like. And if you recall, quadratic equations have a squared term. So ax squared plus bx plus c, something that has a squared term. If it's cubed, x cubed, then that's not quadratic. If it's just x, then it's linear, so at least in terms of the single variable x. However, I guess that was a little bit of a misnomer, because really what I'm looking at is y equals something. Remember that when we're graphing, often we'll use this xy graph, the Cartesian coordinate system. So let me just start with y equal to x squared as an example. I know this is quadratic because I have a squared term for x, okay? So let me just make a little table, and from this table we're going to generate points, and then I'm going to put those points on a graph. And let me just pick a few values. How about -2 for x, -1, 0, 1, and 2. And let's see what is produced on the y side. To get the y value, I just plug each value of x into the equation where I see the x. So this looks like parentheses -2 quantity squared. I always replace this with a set of parentheses if I'm putting a negative in there, just to be sure. Okay, -2 squared is +4, so this is 4. For the next one, y is equal to 0 squared, which is 0. Oh, whoops, that's not the next one. All right, -1, let's put that in there. Squared equals +1. All right, now we're at the 0. Squared, which is 0. Y equals 1 squared, which is 1. And then y equals 2 squared, which is 4. And you might already be seeing an interesting pattern. Let's talk about that. But first, I'm going to make my xy graph. And what do I need to go up to? I need to at least go up to 4 on the y-axis. On the x-axis, I'm going from -2 to +2. Okay, so on the y-axis, 1, 2, 3, 4. And I'll put some negatives just to make it nice and symmetrical. The x-axis, let me make these steps a little bit bigger in appearance, although I'm still going by ones. And that's okay. You have a little bit of freedom with your graphs. Okay, and we have the negatives down there for the y. So my first point is -2, 4. -2, 4, right here. My next point is -1, 1. Okay, right there. Then I have 0, 0, right there at the origin. 1, 1 is here. And 2, 4 is here. And I'm going to try to connect these with the smoothest line that I can, or curve, I should say, because these points don't form a line, they form a curve. They form particular curves actually called parabolas, and there are several things that are interesting about parabolas. But let me just say a few things about this one that are general to all quadratic equations when you graph them. One of those general things is that they all have a vertex. And this point right here, which represents the bottom of this curve, or as you'll see later, you can also have a curve going the other way around. So you can have a smiley face or a sad face that all these quadratic equations make when you graph them. But if you're looking at the very bottom or the very top, that thing is called the vertex. Vertex. And there's something else. You'll notice that there's some symmetry to this. Notice that if I took the left side and flipped it over the y-axis, it would exactly create the right side. And you can see that with the numbers also. We went 4, 1, 0, 1, 4. The line that goes through the vertex, in this case it's the y-axis, It's not always the case that it's the y-axis, but that thing that goes right through the vertex, the line that goes vertically through the vertex, is called the axis of symmetry. Axis of symmetry. And we call it that because wherever the axis of symmetry is located, you can just flip the image around that, and you will get the right picture for the entire graph. So there are a couple important terms. Now there are other terms involved with parabolas and graphing quadratics, but let me just stop there with terminology. And in the next video, I'll just do a couple more examples, and we'll continue like that and build up to a general form of graphing quadratic equations and a general strategy.